Throughout human history, there has been a disease that has struck fear into the hearts of millions. This disease is cholera, a name that alone is enough to send chills down one's spine. Cholera stands apart from other infamous diseases, like the plague or smallpox, in its ability to strike with sudden and devastating force. In regions ravaged by cholera, medical systems often collapse within moments, leaving human defense mechanisms overwhelmed and powerless. From the moment of infection to death, the process can take as little as 8 hours, transforming a living, breathing person into a withered husk. The year 1832 marked a dark chapter in British history, as cholera swept through the nation like a merciless tempest. As the epidemic raged on, the mortality rate among British patients skyrocketed to a staggering 90%, plunging the nation into a state of despair. It was in this dire moment that a young Irish chemist named Shaughnessy stepped forward. He began by meticulously calculating the rate at which patients were losing fluids through diarrhea. The results were shocking. Up to 1,400 milliliters per hour, equivalent to 3 bottles of mineral water, carefully analyzed the patient's excretions and discovered they contained high concentrations of various chemical substances. Chemicals missing from the blood perfectly matched those found in excess in the excretions. This revelation led Shaughnessy to a crucial conclusion. The cause of death was likely not just simple dehydration, but a more severe imbalance in blood chemistry, what we now refer to as electrolyte imbalance. Shaughnessy realized that the conventional approaches not only failed to save patients' lives, but actually accelerated the loss of vital chemical substances from the body, further exacerbating the condition. He vehemently called for an end to traditional therapies like enemas, and proposed a revolutionary treatment plan: intravenous injection of warm water with a concentration matching that of normal blood. However, Shaughnessy's ideas were far ahead of their time. The medical community of the 19th century had not yet mastered the technique of intravenous injection, making his proposals seem like pure fantasy. Many physicians leveled sharp criticisms at his theory, challenging him with pointed questions. Do you truly understand the salinity and chemical composition of normal blood? Have you actually implemented your proposed intravenous injection method? Faced with this barrage of skepticism, Shaughnessy candidly admitted that he had only experimented on a single dog. Such a response, understandably, failed to convince his critics. Under immense public pressure, Shaughnessy ultimately had his medical license revoked and was forced to return to his chemical research. However, even as Shaughnessy's theory was temporarily shelved, cholera patients continued to perish in alarming numbers, and the situation remained dire. It was at this critical juncture that another young Scottish doctor, Latta, stepped into the fray. Unable to bear witness to patients dying one after another, Latta decided to replicate Shaughnessy's experiment on terminally ill patients. After tireless efforts, Latta finally discovered a suitable formula, including the optimal temperature, volume, and frequency of the injections. He vividly described the experimental process. A volunteer patient on the brink of death had a tube carefully inserted into a blood vessel, and saline solution was injected 1 ounce at a time. The patient's sunken cheeks, hollow eye sockets, and collapsed jaw began to show signs of life, and the faint pulse grew stronger. Even more astonishing was that all these changes took place within a mere half hour. After injecting 6 bottles of saline solution, the patient declared in a firm voice that he no longer felt unwell. Latta's experiment was a resounding success, bringing a glimmer of hope to cholera treatment. However, fate seemed to be playing a cruel trick on these brave doctors. Just as other physicians began to read Latta's paper, cholera mercilessly claimed Latta's life. He died at the young age of 37. Latta's untimely death was not only a tremendous loss to the medical community, but also put his injection method at risk of being forgotten. Statistics showed that the success rate of intravenous injections was only 11%, a figure that cast doubt on the method's efficacy. However, later experts suggested that such a low success rate was likely due to immature injection techniques at the time, which led to blood infections. From 1830 onwards, cholera ravaged the Western world, claiming millions of lives and earning its fearsome moniker, the Scythe of Death. However, the nature of this disease left scientists both perplexed and frustrated. Unlike other infectious diseases, cholera seemed to possess a unique mechanism of action that made it difficult for the human body to produce effective antibodies. Most viruses, such as smallpox, influenza, or Ebola, must engage in a multi-layered battle with the immune system when attacking the human body. Once the immune system successfully repels these viruses, the body produces antibodies that provide protection against future infections. But cholera was entirely different. It appeared to be an invisible killer, capable of entering the body even through wounds without triggering any inflammatory response. This characteristic of cholera raised an intriguing question. How could it cause such devastating damage without being detected by the immune system? The answer to this question revealed cholera's astonishing survival strategy and provided crucial clues as to why it was so difficult to eradicate. In fact, cholera bacteria need to reach an astounding number, about 100 million viral particles, before they can truly exert their deadly effects. These viruses enter the stomach through food and drinking water, and only a lucky few survive the test of powerful stomach acid. But once these survivors enter the intestines, they launch a biological invasion that sends chills down one's spine. Even more surprisingly, our immune system mistakenly recognizes these deadly invaders as harmless lactic acid bacteria. This fatal error creates perfect conditions for cholera bacteria to run rampant. The toxins produced by cholera bacteria can cause intestinal cells to open their electrolyte channels, leading to the release of large amounts of chloride ions. This process triggers a cascade of reactions, ultimately resulting in massive excretion of sodium ions and water from the cells. This unique mechanism of action explains why cholera patients experience such severe dehydration symptoms. It also reveals why cholera patients, even after recovery, struggle to develop long-term immunity. Throughout the entire process of infection and recovery, immune cells may never have the opportunity to directly encounter cholera bacteria. However, this discovery also brought forth a larger puzzle. If the immune system fails to recognize cholera bacteria throughout the entire process, how do those lucky survivors manage to recover? The answer to this question led us to an even more miraculous discovery, an astonishing secret involving the water of India's Ganges River. In 1896, an English doctor named Adam arrived in India and encountered a scene that left him utterly shocked. The locals handed him a bowl of water from the Ganges River, smiling as they said, "Come on, young man, drink this bowl of Ganges water." As a doctor, he was well aware that the Ganges water likely contained the remains of numerous cholera victims, and drinking such water was undoubtedly a life-threatening act. However, the Indians' attitude was unexpectedly relaxed. They explained, "Don't be afraid, we've just been through a cholera outbreak. And it's precisely because of this bowl of sacred Ganges water that we were able to dispel the disaster and make cholera disappear. If you don't drink this bowl of Ganges water, we can't guarantee you won't contract cholera." These words plunged Adam into deep confusion. As a scientist, he couldn't understand how water believed to be full of bacteria could prevent disease. With this question in mind, Adam began his research. He first cultured the cholera vibrios from the Ganges water, allowing them to grow in a culture medium. Then, he added a second bowl of Ganges water to the culture medium. If the Indians' claims were correct, the second bowl of Ganges water should kill the cholera bacteria in the culture. Surprisingly, the experimental results confirmed the Indians' claims. The cholera bacteria in the culture medium indeed mysteriously disappeared. This discovery left Adam even more perplexed. What exactly gave the Ganges water this miraculous power? Next, the Indians revealed an even more puzzling phenomenon to Adam. They told him that when the Ganges water was abundant, the area was more likely to experience cholera outbreaks. But when the Ganges water was calm, cholera would disappear. This phenomenon was completely contrary to common sense. Usually, when river water is abundant, the water quality is clear, and the concentration of bacteria is low, making it less likely for people to get sick. When the river water is calm, the water body becomes turbid, the concentration of bacteria increases, and it's more likely to cause disease. Adam left India with these questions, but these puzzles continued to linger in his mind. It wasn't until 20 years later that scientists found the key to solving this puzzle: bacteriophages. Bacteriophages are nanoscale robots from 3.8 billion years ago. They are viruses that specifically hunt bacteria but have no interest in human cells. These tiny organisms are ubiquitous on Earth, including within the human body. They help control the balance of intestinal bacteria in our bodies and kill 40% of bacteria in the oceans every day. This discovery explained why cholera outbreaks occurred when the Ganges water was clear. When the water volume was abundant, the concentrations of both cholera vibrios and bacteriophages were reduced, making it difficult for bacteriophages to effectively control cholera vibrios. But when the river water was turbid, both were highly concentrated, allowing bacteriophages to effectively control the number of cholera vibrios. This astonishing discovery not only explained the miraculous effect of Ganges water, but also provided new insights for humans in the fight against cholera. However, this method of fighting poison with poison obviously couldn't be promoted globally. So how could people in other parts of the world combat cholera? The answer lies in the story of a doctor named John Snow, which will lead us to understand how humans finally managed to control the cholera epidemic. If you were to visit London today, at the intersection of Broad Street and Cambridge Street, you would come across a seemingly ordinary water pump with an extraordinary history. This 170-year-old pump stands as a silent witness to how a doctor named John Snow managed to control the cholera epidemic. Not just in London, but across the entire Western world. Dr. Snow's story takes us back to the mid-19th century, when London was shrouded in the shadow of cholera. Since the 1830s, when pioneers like Shaughnessy and Latta began their fight against cholera, this terrifying disease had been making sporadic appearances in England. By 1854, London had already endured over a dozen large-scale cholera outbreaks. Faced with this seemingly incurable disease, Snow decided to approach the problem from an entirely new angle. He astutely realized that relying solely on treatment was far from sufficient. During the peak of cholera outbreaks, hundreds of people would fall critically ill simultaneously, causing medical resources to collapse instantly, leaving doctors unable to treat all patients in time. Therefore, Snow turned his attention to the mystery of cholera transmission, hoping to solve the problem at its root. Snow first focused on cholera's characteristic of suddenly appearing and disappearing. On August 31, 1854, a severe cholera outbreak occurred on Broad Street, claiming 300 lives in just 3 days and causing 3/4 of the residents to flee the area within a week. Faced with this situation, Snow resolutely entered Broad Street and began his investigation. His research method was pioneering in modern epidemiology. Snow first obtained a list of the deceased, then raced against time to visit the neighbors of the deceased, gathering detailed information about their living conditions before death. On a map, he used a horizontal line to represent each death. Through this method, he quickly discovered an astonishing pattern. The areas with concentrated deaths all had a common feature, a well or water pump at the center of the area. Particularly around the Broad Street pump, the black lines were alarmingly dense. This discovery convinced Snow that there must be a problem with this pump. To further confirm his hypothesis, Snow continued his in-depth investigation. He discovered that the Lion Brewery next to Broad Street had not a single worker infected with cholera. Upon inquiry, it turned out that the brewery provided free beer to its workers, and they never drank water. This discovery further strengthened Snow's judgment. The probability of the well being contaminated was extremely high. As the investigation deepened, Snow finally found the patient zero, an unfortunate baby girl who had died from diarrhea. After the baby's death, her mother had thrown her used diapers into a cesspool. This cesspool was only 3 feet away from the Broad Street pump. At Snow's suggestion, people dug up the cesspool and the Broad Street pump, discovering that the pool wall had long been damaged, allowing sewage to seep into the well water. Through a series of meticulous investigations, Snow ultimately proved that water was the sole route of cholera transmission. This discovery explained why hundreds of people suddenly fell ill simultaneously, because the well had been contaminated. And when terrified residents began to flee, they unwittingly contaminated wells along their escape routes with their own excretions, further expanding the scope of the epidemic. Based on these findings, Snow proposed a simple yet effective solution: build sewers to completely separate sewage from drinking water. He firmly believed that as long as London's sanitary conditions improved, cholera would become history. As it turned out, Snow was right. As London became cleaner, cholera gradually disappeared. However, like many pioneers who made significant contributions to science, Snow did not live to see the fruits of his labor. 3 years after proposing this revolutionary discovery, Snow passed away due to illness, reportedly also infected with cholera. But to maintain public morale, he chose to conceal the cause of his death from the public. In 2007, the British Medical Journal selected the most important medical inventions of the past 150 years. Surprisingly, neither antibiotics nor vaccines topped the list, but sanitation. This seemingly simple concept was recognized for giving humans the ability and awareness to maintain clean environments, food, and water sources. It's not just a medical practice, but a marker of human civilization entering a new stage. Looking back at 19th century London, it's hard to imagine how terrible the sanitary conditions were. Interestingly, one of the reasons high-heeled shoes first became popular was reportedly to avoid stepping in the excrement that was ubiquitous on the streets. This detail vividly illustrates the poor urban environment of the time and helps us better understand why the spread of hygiene concepts was so important. The Western medical community even views sanitation as an important sign of human civilization's progress. In many parts of the world, especially in resource-scarce areas, cholera remains a serious threat. People in these places are using the seemingly simple weapon of practicing hygiene to resist the scythe in the hands of death, while enjoying the conveniences brought by modern medicine. In today's globalized world, a public health problem in one region can quickly evolve into a global crisis. Therefore, improving sanitation standards globally is not only for those regions still struggling with diseases like cholera, but also for protecting the health of the entire human society. Finally, Dr. Snow's story teaches us that when facing complex problems, sometimes the most effective solutions might be right beside us. It encourages us to look at the details of daily life with innovative thinking, because the next world-changing discovery might be hidden in things we take for granted.